Hello, everyone. I'm Kelly Eversole, the Executive Director of the International Alliance for Phytobiomes Research, and I want to welcome you to our webinar today. We are joined by Claire Boryan from the National Agricultural Statistics Service of USDA, or what we all call NASS, and always forget what the acronym stands for. But anyway, I want to welcome everyone to the webinar. And before we get started, I want to give a quick overview of what the Phytobiomes Alliance is, so you can have some context to why we're holding this webinar. So we are a nonprofit, hope you can see my screen, nonprofit consortium of industry, academic, and governmental scientists. We have a number of sponsors ranging from academic institutions all the way to governmental agencies, large companies, small companies, and startup companies that are really truly startup and are still in their funding stages, trying to raise money to develop their projects. So what is phytobiomes? A lot of people automatically think that we're just talking about a plant microbiome, but we're not. We're talking about the entire complex system of plant-based agriculture. And it's really the concept of a plant, or the phyto being in a biome, a specific space, or a specific farm or field or warehouse if it's urban or vertical agriculture, and all of the different components, biological and geophysical components that interact with that, and as well as how they're influenced by management practices. So our vision is that by 2050, all farmers will have the ability to use predictive and prescriptive analytics based on those geophysical and biological conditions for determining the best combination of crops management practices and inputs for a specific field for a given year. Just to let everybody know, we are having in 2022 a conference that will be covering the full breadth of all of our topics in September in 2022 in Denver, and we will be opening up the call for abstracts before too long. And before we start, I just want to let you know that the webinar is being recorded and it will be posted on the Phytobiomes Alliance YouTube channel. The presentation will be followed by a Q&A session, and you can put your questions, even during the presentation, you can put your questions in the Q&A panel. You can also chat with the organizers or the presenters via the chat button. And you can already download the handouts from both this presentation that I've just given, as well as what Claire has provided. So as you can imagine, if we're thinking about the entire vision of the Phytobiomes Alliance, understanding crop condition and soil moisture is one key component to us being able to develop these kinds of predictive analytic tools. So we're really pleased to have Claire Boryan with us today. She is the Senior Geographer with the Research and Development Division of the U.S. Department of Agriculture, NASS. She has extensive experience in geospatial analysis and remote sensing. Her research focuses on applications using Earth observation and geospatial data to improve agricultural statistics. So at this time, I'd like to welcome Claire to take over and also introduce Rick Mueller, who has joined us from NASS. So thank you very much, Claire. It's all
Thank you, Kelly. Thank you, Kelly. Thank you for inviting us here today to speak. My presentation is on Crop-CASMA. It's a web-based GIS application for soil moisture and vegetative condition monitoring. In this presentation, I'll provide some background information on the NASS mission, the NASA SMAP mission, that's Soil Moisture Active Passive Mission. It was launched in 2015. And then I'll begin to talk about our Crop-CASMA web application and kind of give you a brief introduction to the interface. This was actually just released in April, beginning of April of this year. I'll talk about Crop-CASMA data, which includes soil moisture data and vegetative condition data. We'll have a demonstration also. We have a recording that's also going to go out on your YouTube channel that shows how to kind of use Crop-CASMA. And then I'll talk about some of the applications that are already, or groups that are already using Crop-CASMA. And then at the very end, I have information on resources about some additional training, peer-reviewed papers. And I'm going to go into the background. So I work for the USDA National Agricultural Statistics Service, or NASS. And our mission is to provide timely, accurate, and useful statistics in service to U.S. agriculture. And we do this using a variety of survey, census, geospatial, and remotely sensed data, including soil moisture and vegetative condition data. Well, why is soil moisture information important? Well, soil moisture data are critical to plan for crop planting, forecast yields, track droughts, monitor excess moisture conditions, and monitor floods. So in 2015, NASA launched the Soil Moisture Active Passive, or SMAP, mission. Now, SMAP tracks soil moisture conditions around the globe. So every 3 days, SMAP acquires soil moisture data of the entire Earth. And we have a nice URL to a SMAP video at the bottom. So what is Crop-CASMA? First, I want to acknowledge the scientists that worked on the project. This was a collaborative effort between NASS, my agency, my colleagues, Dr. Zhengwei Yang and Rick Mueller, NASA, Dr. Bindlish and Liu, and also scientists from George Mason University, Dr. Zhang, Zhao, Sun, and Di from the Center of Spatial Information Sciences and Systems. Can we just go back? Yeah, thank you. And then from ARS, it's Dr. Wade Crow. And again, I'd like to acknowledge my colleague, Dr. Zhengwei Yang, who's really one of the key developers of Crop-CASMA. And I have his his contact information there. And this was supported, the support for this work was partially funded by the NASA Applied Sciences program. So what is Crop-CASMA? Crop-CASMA is a web-based geospatial application. It's designed to facilitate the utilization of remotely sensed geospatial, soil moisture, and vegetative index data. The data are derived from NASA's SMAP and moderate resolution imaging spectroradiometer missions. It's another NASA mission, and it's designed to assess conterminous U.S. soil moisture and crop vegetative condition. So this is just an overview of the Crop-CASMA interface and so what some of the tools can do. So here the picture on the right is what, if you went onto this URL, this is what Crop-CASMA looks like. But within it, there are tools for visualization, analysis, anomaly assessment, animation, zonal statistics, data dissemination, and outreach support. So see, these are some of the major tools. We'll go into more detail on this in the video, but we've got a toolbar. This is on the left side, a toolbar, a catalog, which shows all the different types of data that are in there, a layer manager, where you can determine, you put in which ones you want to work with. And there's just some of these other tools, zonal statistics. You can make your own maps of the data and put them in reports, map swipe, download the data yourself. So now I'm going to get into the data, the soil moisture data. First, the NASA SMAP mission, it measures soil moisture from the top 5 centimeters of the soil column. The SMAP Level 4 data sets assimilate SMAP observations into physically based numerical models of the land surface water, energy, and carbon cycles. So the Level 4 soil moisture data has the following characteristics. Topsoil moisture, as I said, of the top 5 centimeters, and root zone soil moisture, which is the top 1 meter. The data is 9-kilometer spatial resolution, and actually you have daily multiple outputs. So every 3 hours, the data is acquired. So that's 8 measurements per day. And this is the data that's in Crop-CASMA. So the data, again, the data in Crop-CASMA and the data derived from SMAP, we've got the 9-kilometer data, that's 3 hours, and then they have data that's aggregated to daily and weekly, and that's topsoil and root zone soil moisture. And then there's a new product, which is a 1-kilometer product. It was developed as part of this grant, and that is daily, 3-day, and weekly topsoil moisture. And so for both the types of those products, there's anomaly data, and there's also some NASS categorical condition data. So taking that soil moisture data and converting it into categories. This is an example of some of the 3-hour data. This was a rainstorm that went through Iowa on September 21st in 2016, and this is topsoil moisture. And we have a legend on the left, but when you see more of the darker blue shades, that's when there's more soil moisture in the soil. But there was a rainstorm that by the afternoon, it was being that information was being collected and could be detected in the SMAP data. And you can see that from 1:30 to 10:30 is more soil moisture, more blue color. So this is actually the daily average data. So they take that 3-hour data and it's averaged to create daily data. So it really comes down to the application that you're doing, whether you want to look at it hourly or daily or weekly. So this is also the same location in Iowa from September 18th to the 25th. And this is the daily data. And you can see the from the 22nd to the 25th, there's more of that soil moisture evident. And this is showing some weekly average data. Again, if you want to understand, it depends on your application, but if you want to look at, a week in 1 year versus a previous year. So in this example, you're looking at September 2015 to September 2016, and 2016 was a wetter period of time. So a new product that is in Crop-CASMA that was developed as part of that grant is a 1-kilometer SMAP by the scientists, is a 1-kilometer SMAP data. It's derived from SMAP level 2 data. This is a modeled product using MODIS, surface temperature, and soil texture data. They refer to it as their thermal inertia model. It is 1-kilometer resolution, topsoil moisture only. And for this product, you have a 3-day and a weekly composite, and it does have the similar derivative products like the anomaly data and the categorical data. And in this example, we've got the weekly average topsoil moisture in Iowa for a period of time. You can see what that looks like. And one thing I just wanted to point out here is all of the SMAP products are heavily validated. This is a graphic that was included in a paper that I have cited at the bottom. And this shows the in situ sites for their validation efforts. So this is the soil moisture validation network. And it shows the error for the 1-kilometer SMAP data, and the lower errors are in blue. And they're always, the scientists are looking at trying to be below 0.04. This illustration shows the difference in the spatial resolution between the 9-kilometer SMAP data on the left and the 1-kilometer SMAP data on the right. This is the same time period in Iowa in 2021. And you can see the, the different, it's more blocky at the 9-kilometer level. Other data that's available in Crop-CASMA is a crop soil moisture anomaly data. For many applications, what people want to know is how different a time period is relative to the average. So that's why you have this data. So this is soil moisture anomaly index, which indicates the deviation of the current soil moisture level from the historical soil moisture average. Another type of data that's in Crop-CASMA is the NASS categorical soil moisture condition data. So on the left, we have our soil moisture a soil moisture map. This is the data. Well, the scientists developed a way of converting that soil moisture information into these NASS categories. And we use these for our soil moisture reports, and they're part of our crop condition assessment, crop progress and condition reports. These are very heavily used by the public, and so we wanted to be able to use this SMAP data in here. So that's what we have here, and the NASS categories are very short, adequate, and surplus. This is just an example of that same thing, where on the left, this was in February 2021 in Arizona. It was very dry. The SMAP soil moisture data is showing us that's with those red colors. You can see the legend, very low soil moisture. But then in the middle, we have our categorical soil moisture, the conversion. And on the right, I do want to point out, so the gray, that is a crop mask. So when we put a crop mask over something like this, the gray, all you're seeing is the cropland below it. So there's not a lot of cropland relatively in Arizona, but actually for that area and for those crops, most of that is just considered adequate for the crops that are grown there. So now I'm going to should talk about the vegetative condition data that's in Crop-CASMA. So Crop-CASMA can provide daily and weekly vegetative condition products from 2000. I want to mention that the SMAP data, the soil moisture, is from 2015, because that's when that sensor was launched, and the vegetative condition is from 2000. So the data is derived from MODIS. It's another NASS sensor, and it's NDVI, which is the normalized difference vegetative index, VCI, which is vegetative condition index, and MVCI, which is the mean vegetative condition index, which is the NDVI anomaly. A little more detail for anyone who's not familiar, but the NDVI, or normalized difference vegetative index, it quantifies vegetative condition by measuring the difference between the near infrared and red light. It really gives you a sense of how healthy the vegetation is. So healthy vegetation reflects more near infrared and green light compared to other wavelengths and absorbs more red and blue. And this has been used since the 1980s, a very popular index. There's also vegetative condition index, or VCI, and VCI compares the current NDVI to the minimum historical NDVI value observed in the same period in previous years. And it indicates where the currently observed NDVI value is situated between the historical extreme values, the minimum and the maximum relatively. And again, scientists decide which of these indexes is appropriate for their application, and the VCI is commonly used to identify drought and determine the onset. And there's also a mean vegetation condition index, or MVCI. The MVCI represents the deviation of the vegetation to normal vegetation, or the multiple year mean. And again, that would be from the year 2000. Now we have a video that will give you a sense of how Crop-CASMA works. Just sort of imagine clicking on the URL and you're looking at Crop-CASMA, and I will be speaking, and my colleague Avery Sanborn, when we did this video, she's moving around the interface. So maybe look for that mouse and see what it's showing you.
This is the Crop-CASMA interface. On the left side of the interface, you can find several different tools. The catalog includes all the soil moisture and vegetative condition data available for selection. The layer manager serves as the table of contents for your map. You can toggle layers on and off by clicking the eye symbol, and remove layers from your map by clicking the trash can symbol. Other major tools in Crop-CASMA include calculate zonal statistics, create PDF maps, create profiles, build composites, data download, map swipe, and map animation. On the right side, there is a tool to zoom in and out for map visualization and a tool to toggle the map legend on and off. Crop-CASMA also has several auxiliary layers for visualization. You can select boundaries by region, state, district, or county. Global land cover is used as the base map. The global land cover will not affect any calculations or analysis. Water layers include lakes and rivers at the national and regional level. Road layers include major highways and freeways at the national level. The cropland data layer, also referred to as the CDL, is for visual reference. It will not affect any calculations or analysis. The crop mask layer is generated from the most recent 5 years of cropland data layers. It will not affect any calculations or analysis and limits visualization of soil moisture and vegetation data to cropland only. Crop-CASMA disseminates several NASA soil moisture active passive SMAP data products and their derivative data products. SMAP 9-kilometer level 4 soil moisture measurements are volumetric soil moisture, which is volumetric water content in the soil. These measurements are the ratio of water volume to soil volume. Crop-CASMA hosts topsoil data, defined as the top 6 inches and sometimes referred to as surface soil. It also hosts subsoil data, defined as the top 3 feet and sometimes referred to as root zone soil. These data are provided in daily and weekly increments. Additionally, Crop-CASMA hosts soil moisture anomaly data, which measures the deviation of the current soil moisture value from the normal soil moisture level. The normal soil moisture levels are represented by a historical average soil moisture value from 2015 to present. There are also weekly categorical soil moisture condition data. These data have been converted from NASS SMAP level 4 soil moisture values to predefined NASS or National Ag Statistics Service soil moisture categories. These categories include very short, short, adequate, and surplus. Finally, newly developed NASA 1-kilometer high-resolution soil moisture data products are also available. These data are derived from SMAP, MODIS land surface temperature, and soil texture data. This is a modeled data product that is only available for topsoil moisture and includes anomaly and categorical soil moisture condition data. When you zoom in, you can tell the difference in pixel size between the 1-kilometer and 9-kilometer resolution data. In Crop-CASMA, the surface reflectance daily 250-meter MODIS data are utilized for the vegetation index calculations. Normalized Difference Vegetative Index, or NDVI products, are available daily and weekly from 2000. NDVI provides information on vegetative health and vigor. Vegetative Condition Index, or VCI products, compare the current NDVI to the minimum historical NDVI value observed in the same period in previous years. The VCI indicates where the currently observed NDVI value is situated between the historical extreme values, minimum and maximum relatively. Mean Vegetation Condition Index, or MVCI, represents the deviation of the vegetative condition from the normal vegetative condition, which is represented by the NDVI historical average value. The calculations used to create all of these vegetation condition products are included in the Crop-CASMA user guide. The Area of Interest toolbar includes various functions for defining an area of interest for data analysis. You can select an existing administrative boundary such as region, state, district, or county. You can also draw your own area of interest using the polygon, rectangle, or freehand tools. Finally, you can import your own area of interest in shapefile format or export an area of interest for use outside Crop-CASMA. Once an area of interest has been defined, many additional functions can be conducted. The Statistics tool calculates statistics for an area of interest for the currently loaded top data layer. In this case, SMAP 9-kilometer topsoil anomaly daily data for June 7th, 2021. This tool presents a table of acreage calculated from the pixel count of every category within the area of interest. You can save the table as a CSV file or view a pie chart or histogram of the data. The data can be filtered by cropland areas only, which is based on the crop mask auxiliary layer. With the area of interest still selected, you can create a PDF map of the data and select a customized title, paper size, and which overlaid boundaries to include. Finally, you can download the raw data from Crop-CASMA for the selected area of interest. The swipe tool allows you to compare two different data map layers in detail. After clicking the swipe button, you can select two images to show on the map. In this example, the left image will be SMAP 9-kilometer topsoil weekly average data starting on May 20th, 2019. The right image will be the same data, but 2 years later, starting on May 17th, 2021. Using the swipe tool shows you that areas like California, North Dakota, and Iowa were much wetter or had higher soil moisture content in 2019 when compared to 2021. This is important information for farmers, policymakers, agribusiness, and for environmental assessment. Crop-CASMA provides the option for a one-click report using the paper airplane symbol on the right side of the interface. After you select a predefined area of interest from the drop-down menu, Crop-CASMA generates tables, charts, and maps on the fly. The report can be downloaded as a zip file with a PDF map and CSV data table.
Okay, so that was our demonstration. And then the next thing I want to talk about are some NASS soil moisture data applications. So as I said, Crop-CASMA was released, excuse me, on about April 1st. And one thing that's already been useful is that these soil moisture maps that you can produce quite easily in Crop-CASMA are being used in the NASS crop weather reports. Here's an example for California. These are done in every state. They're actually very popular by the public. And this is the California crop weather. And by being able to have that illustration of the soil moisture conditions for that week, it's really helpful to understand the varying levels of soil moisture across the state. Another way that the soil moisture data can be used is, we do these surveys, soil moisture surveys, and they're done at the county level. Well, sometimes there are counties that have no response. So the SMAP data certainly can be used as an imputation data source for non-response for the soil moisture survey data. Also, it can be used for decision support for the weekly categorical soil moisture condition assessments. They can use those NASS reported percentages and compare it to the Crop-CASMA percentages to see how those compare. Now, this is an example of how Crop-CASMA was just used in the last week. So we have a disaster team in NASS, and there was some flooding that took place between June 7th and the June 13th. It was in eastern Arkansas and western Mississippi. And the Delta region offices were very concerned with understanding what cropland was impacted. We were also running our June surveys at the same time. So what the disaster team did was they looked at the topsoil moisture anomaly data. And in this map here that was produced in Crop-CASMA, you've got the crop mask on there. So all you're seeing is the cropland, the cultivated land. And the blue colors are showing you where there's high anomaly levels in that region. But the topsoil moisture anomaly greater than 30% was considered to be very abnormal. And in this example, the analysts determined that about 35% of the cultivated area in the Delta region was above 30% soil moisture anomaly. And the analysts also looked at the specific crops that were experiencing those conditions. For this, they use the previous year's cropland data layer. If there's questions about that, we can talk about that at the end. We have a crop-specific land cover product that is used for this assessment. So we used last year's CDL, and it was intersected with the anomaly data to determine the specific crops that were planted in the soils with greater than 30% more soil moisture than normal conditions during that period from June 7th to the 13th, 2021. And that's what that information in this table here, this was provided to our Delta region and to our Agricultural Statistics Board. This is non-confidential information using the NASS estimates and this cropland data layer of previous years. But it's showing for Arkansas, Louisiana, and Mississippi, the total acreage for corn, soy, cotton, and rice from last year, and the estimated percentage of those types of crops that would be planted in those really highly inundated soils. We also looked at the categorical data. This is an example of a soil moisture maps with the categories. So again, on the right, this map was made in Crop-CASMA. And this is the same thing with the crop mask, but you've got your soil moisture categories of very short, adequate, and surplus. And the analysts determined that in that region, during that period, 43% of the cultivated area in the Delta region was in surplus. Again, they did the same thing with trying to get some crop-specific information. This is just an idea of what's going on, but the specific crops in the soils with these surplus soil moisture conditions during that period from June 7th to the 13th, just last week. And you can see, again, for Arkansas, Louisiana, and Mississippi, and this is using that topsoil moisture categorical data based on the 1 kilometer data from June 7th to the 13th. And you can get a sense of for corn, soy, cotton, and rice, you know, the 4 major crops in that region, kind of the percentages of those crop types that were in surplus. So some other ways that Crop-CASMA is already being used for in NASS research, it's being used for early planting estimation modeling research. We have crop growth models for yield prediction, and also we're using it in crop growth and condition modeling. Some more potential applications which actually have already come to fruition. Again, supplementing that NASS soil moisture reporting. For example, as I showed you in the California, the maps for each of the states for crop progress and condition. Again, these for freely available soil moisture maps for outreach. Anyone can make it and put it into a report. We just used it for drought and flood disaster assessment and monitoring. It can be used for crop growth and condition monitoring and modeling. It can be used for water resource management, market decision support, and planting and irrigation management decision support. Right here towards the end of the presentation, I wanted to include some resources for all of you in case you are interested. You know, how would you, if you wanted to learn more about Crop-CASMA, I have a link to the user guide. The user guide is a wealth of information about all the data, you know, just lots of information with lots of examples on how to use the tools. It's just very helpful and it's right there. And there's also a wonderful developer guide, which is if someone wants to use the data, the web services, which a lot of people use the data that way, where they pull the data into their own applications. So that you'd look at the developer guide for that. Also, if you actually wanted to understand more about remote sensing and how, you know, these types of applications with remote sensing, NASA has some wonderful applied remote sensing training program. They have free classes. Some of them you can take live, and all the classes are, and they're on many different topics, and they are recorded. So for example, if you were interested in a topic, you can go and click on that and you can download the slides, which have a recording over them. And they're wonderful classes for learning about these topics if you are interested in learning more. And finally, I wanted to point out there have been many peer-reviewed papers written on these topics, on not just the soil moisture, but the vegetative condition, written by the scientists involved in this project. So there's the list of those here. And finally, I want to say thank you for myself, my colleague Avery Sanborn, who helped prepare this presentation and do the prepare the video that will be posted on your YouTube channel. And again, I want to acknowledge my colleague, Dr. Zhengwei Yang. He is the developer, the Crop-CASMA developer. His contact information is here for technical questions. He really does know all about all these things. And I've got the URL for Crop-CASMA, if you want to see that, if you want to go directly to it. And then there's also a nice NASA video on the SMAP mission. And again, talking about why we care about soil moisture and why it's so important to gather this information. But thank you.
Claire, thank you for a very fascinating overview of this wonderful tool and resource. So just to remind everyone, if you have questions that you would like to ask Claire or one of her colleagues, which I believe we do have a colleague that in case there's a specific question that is asked. So please put those in the question and answer or the Q&A panel. So Claire, if you don't mind, would you introduce Dr. Mueller?
Yes, so this is Rick Mueller. He is also from the National Agricultural Statistics Service. He's my colleague. He is actually the head of the Spatial Analysis Research section, which I am in, and he was a collaborator on this project with my colleague, Dr. Zhengwei Yang.
Great. So thank you very much for joining us, Rick. It's great to have both of you here. So there are, you know, we are starting to get some questions come in. And the first question that comes in is one that I actually had. I know this is US centric data, but at least I think I've read at various points that there are efforts ongoing to do something similar internationally and to try to build this on a global basis. Maybe that's part of the climate change efforts, research efforts, et cetera. But to what extent do you see this kind of tool being able to be used in other countries?
Well, and I'll speak and then Rick, if you want to add more, certainly the data is global. Okay, so this web application is US, right? The data is global. Remember, I said every 3 hours, every 3 days. But there are other web applications. I'm just thinking, Rick, do you remember? So we have a foreign agricultural service. We have a USDA foreign ag service, and they have, I think it's GADIS. Rick, do you remember what they're?
Yeah, it's GADIS.
GADIS. So the foreign ag, so every group has their own focus, right? Our focus is US, right? And foreign ag service, they have GADIS, and we can provide that link later, because I think we talked about if there's questions, if we get a list of all the questions, we'll supplement. But GADIS, it has the SMAP data in GADIS, right, Rick?
I'm looking right now. I'll post it on the URL on the chat.
Yes, and also I'm just trying to think, I guess there's another resource, and I think different resolution of SMAP data is in, but as Google Earth Engine. There's something called Google Earth Engine, which is again free for researchers, and we started using it totally that way. We now have a license, but because if you're using it for production activities, you're supposed to get a license. But Google Earth Engine is definitely worldwide, and the data is in there. And I think the Foreign Ag Services version of it is in Google Earth Engine, if I'm remembering correctly. Great. And definitely the vegetative condition data is in Google Earth Engine.
Right.
And in GADIS, the Foreign Ag Service web application.
Right, okay. You mentioned the web services approach. Are there easy ways to simply download all the data, including the global data, without going through an API?
I don't know the answer to that. Do you know, Rick?
No, I don't think you can download an entire country. That's too much load on the system. You can download areas. I think it might be limited to like 2 million square kilometers. But it has to be throttled.
So with the web services, you're not actually downloading it. You're kind of pulling it in, right? So that can help, but yes, I don't think they let you download massive amounts at one time.
Right. Okay. Let me just make sure I'm not missing another question here about that particular component. Okay. So you mentioned that the NDVI, or the vegetative data, has been there since 2000. And am I correct? Do I remember correctly that the soil moisture data has been there since 2015?
Yes.
And how does the weather data interact with both of these data, with all of this data, and from a historical perspective? Because that data does exist, but is it brought in to the NASS database?
So, for example, in Crop-CASMA, you just have those two, right? But certainly the soil moisture is affected by weather. That's how you get the soil moisture. Right. And we are currently, I'm working with a team on some early estimation modeling, and we want to understand the impact of these weather events, and we're pulling in all of it at the same time. So Crop-CASMA has these, you know what I mean? But you're right. For other types of modeling, you need to have, precipitation and all the other things too.
Right, and I guess
that answers your question.
Yeah, it does, and that, that's kind of what is that vision that you have for the next steps. How do you, what are your plans as you go forward, and what do you see as some of the areas in which you want to become more aggressively involved in developing tools and resources?
Yeah, so that's a good question, and maybe that's a Dr. Yang question. But yeah, I mean, I know our modeling work is not developing tools, you know what I mean, to put out there, I don't know, Rick, can you answer that question? Do you know?
Well, in some cases, when we're looking at, climate data, weather data versus the sensor data that we're putting out, the sensor is almost capturing this information on a near real-time basis with SMAP. So it's noticing whether the soil is abnormally dry or abnormally wet within a day or two of the event happening. So it's giving you a real-time view versus when you're on the ground and you're looking, does this field look like it's under stress, or is the pasture lagging in certain condition? Well, the satellite will give you a more of a real-time impact of what's happening before you maybe see the big picture of, oh, we need to put on the irrigation because the ground is really it's under stress, or there's excessive evapotranspiration going on.
Yeah, I can see how it would be extremely useful for that real-time situations, in terms of crop management practices, or even, trying to think about in some of the future aspects of using microbes, biological products that may increase the drought resistance for a crop, that if you see what's happening, you might be able to add an additional spray, a foliar spray or whatever to the crop. I'm curious though as to what when we look at what our vision is for predictive analytics and being able to develop in advance what growers might need to be doing, that requires having a lot of this other data that comes in, whether it's the soil quality data, et cetera, and trying to overlay all of those. To what extent do you see these, if you just look at Crop-CASMA as it is now, to what extent do you see it as able to predict and to be used in a predictive manner? So, for example, and I know in the weather world, 15, 20 years of data is not very much data,
right,
for prediction. So, but assuming as we move forward that gets refined, is there a way in which you could actually use these data for predicting what the potential is for soil moisture problems, particularly if you can overlay the weather maps, plus that would include some predictive aspects?
well, I was going to say, again, I know internally we're working on that type of modeling, and we're using this data, but we definitely are using other data as well, and we're doing predictive work. For us, we're doing predictive crop planting, what types of crops, but then we're also doing where we're predicting where there's event times where people can't plant, right? NASS wants to know when, for example, in 2019, there was extensive kind of flooding, wetness in the Midwest,
Correct.
so, what, and they want to understand that. So we are doing that predictive work. I don't know that that's in this tool, you know what I mean? This, but I don't know, Rick, do you have more to say about that? You definitely
I mentioned
all those kinds of data. I'm sorry, Rick.
I mentioned evapotranspiration. That could be some of the next tools we're looking for, because that gives you a real good indication of early warning if you're having a flash drought or something like that. And
Right.
To no extent, NASA's continually launching new missions in the near next 5 to 10 years, and we are very aggressive about seeking this technology and seeking science grants so that we can add on to the capabilities of what our current system allows. Because right now, we have a soil moisture monitor and we have a vegetative condition monitor. In the future, maybe we have, additional predictive algorithms that show, evapotranspiration or potential, or, water shortages. We add additional dashboards, those kind of things. So we're open and looking.
So to that point, you'd be quite interested in collaborating with scientists who might have an interest in helping to develop some of these add-ons, or whatever it might be. Is that correct?
That is correct.
Okay. So to that point, one of the things that I kind of that at least from the Phytobiomes Alliance we've been very interested in is what's the impact of climate and particularly extreme weather events on the microbial populations within the soils. So, we could potentially, this is we don't have data to cover all areas, but given the fact that you can really take your data all the way down to a county level, there could be the potential for us to begin sampling in that county and start pulling together data that could be used for developing prediction capabilities, whether it's indicator species of the microbes, or even, looking at it from a standpoint of, okay, we've had a major flood in the Delta. So what has happened to the microbial population there, and how is that going to actually impact the crop production in the subsequent year? So are those things that, I know you've been focusing really on the geophysical aspects, but trying to bring in those biological aspects could be quite interesting as well.
Some of that might lead into the scope of like Agricultural Research Service.
Sure.
They're looking more at the micro level. We're looking at the national level because that's our mission, is to cover,
Right.
Domestic agriculture. But when you start talking microbes and field level, that's a little bit beyond the scope of our operations at this point. But to say, if there was the capability of being able to scale this to a bigger picture, larger area, then you really attract NASS interest.
Yeah, so one of the effort, and this is still dealing with geophysical and not just the biological. There, of course, the soil sampling effort that's underway at a national level to try to get that data at a national level. So something like that might be an add-on, for example, that you could actually see what the soils are, and at least at the time of the sampling, that doesn't give you the, the real-time data. Is that correct?
Potentially, absolutely. Yeah.
Yeah, and are you working with, so that's mostly been led by the National Resources Conservation Service out of USDA. Are you working with them at all in terms of that? Or have they even approached? Yeah.
Yeah.
So I know that
you're talking about the soil moisture network. Is that what you're talking about there?
No, soil sampling. They've actually
soil sampling. No. Yeah.
They put together tier.
Yes.
A group of tiers, what they call the tier 1 samples that include about 18 to 20 metrics that measure a particular soil sample. They're trying to sample the entire country, and of course that's going on internationally as well. So my interest would be, is there a way in the future we could see that could all be combined?
So for example, again, for this other project, that I reached out to the NRCS soil scientists to kind of determine, because the Sergo data is complicated, right? For people who aren't experts on that data, right?
Yes,
very complicated.
Very.
So the best thing to do, I felt, was to go right to them and say, this is our problem. And they were very helpful in helping us determine, the appropriate attributes of their data that would be appropriate for our application. But yes, you're right. The soil data that's the way we've been in touch with them, but not for this.
Yeah, so we've had kind of a follow-on about generally there is a lot of interest in using artificial intelligence, machine learning. I have a long-standing interest in something called deep learning, which is unstructured data, and where you're really, the beauty of it is one layer upon layer. You just keep adding layers and you refine your predictive capabilities. And that then gets to the issue of how we get at that raw data for people who may be wanting to develop things that would be specific to that. So maybe that's something to think about in the future. I know the reality of it is, and as you said, Rick, it's a massive database. It's, it would totally bring, and I've seen this happen before in genomic sciences, when you have a big database and everybody is all of a sudden trying to download at the same time, 18 gigabytes of data or whatever, and it totally freezes the system. So you don't want to create that kind of scenario. But I guess in the future, where we're looking at the possibilities of quantum computing and also the cloud-based infrastructure where we have distributed networks, that might become more of a possibility as we move forward. So is that something that you're at least thinking about? Or I know quantum computing is way off, but at least it's moving forward.
What do you think, Rick? Are they thinking about?
I mean, we're just trying to think about getting our surveys out on time. That's our most important priority.
Yeah.
But when you think about like the future and high-end, high-capacity computing, yeah, we're looking on the satellite side or the geospatial side is, we're really tasked at 30 meters. We want to move down to 10 meters of resolution. Maybe in the future we'll be down to 1 meter, but then getting down to microbial levels, that might be beyond the scope of NASS, and again, more in the wheelhouse of NRCS or ARS, because they are the ones that are worried about that environment more such than we.
Yeah, I guess even from a microbial standpoint, one of the issues, of course, with farm data is confidentiality and proprietary data. And so, in fact, even in the idea of microbial sampling, for example, we're thinking that we might want to have county level data, that every sample that was taken in a county, we don't have it down to that 1 meter, but it might be we have an estimate in a county. And I think you're right, even in terms of working with the Agricultural Research Service, that they would be quite interested in that, but also potentially the Animal Plant Health Inspection Service, because one of the things that these weather and your models can actually potentially be useful for is prediction of disease and what's happening with what's showing up. And that's without regard to the microbial data, because some of the drone capabilities, the imaging diagnostics that are becoming available are really moving forward. So it'd be interesting to see where we are in a couple of years for all of this. So
it's changing fast.
It is changing very fast, and the capabilities are really amazing. And I think one of the things that's important for us and for the community at large is to try to ensure that the scientists and the industry actually knows what's available, and the kind of work that you guys have been doing. Particularly, I mean, I've been very fascinated with the NASA Harvest effort, and the fact that you guys are working closely with NASA is something I think a lot of people are not aware of, and I think that's another avenue for us to bring tools to growers in the future.
Well, we're not a funding agency, we're not a space agency, so we have to seek opportunities when we can grab it. And when NASA puts out these science announcements for proposals, we are certainly watching them to fit, because Crop-CASMA was built from like a NASA proposal. It's from their
I didn't realize that.
Yes,
absolutely.
That's awesome. Yeah, I did not know that. That's really great. So
yes.
Yeah.
So in that collaborator page and it has the grant. Yeah.
Oh, okay. I missed that at some point. So, but that's also, again, an opportunity for scientists who may be interested in putting in a proposal and having you as collaborators or on that project as well. So not only with NASA, but some of the other agencies. I mean, the one thing that could be interesting in the coming year, of course, will be the National Science Foundation and their new emphasis on informatics and data. So that, I mean, there may be some real opportunities there to really build up the NASS database. So, well, that's all for today, unfortunately. But I mean, I could talk about this for another hour. But I really appreciate both of you being here and for the great presentation, Claire. And I think the video was really excellent. And just as a reminder, all of this information will be on the Phytobiomes Alliance YouTube channel, and also there will be a link on the Phytobiomes Alliance webpage, which is www.phytobiomesalliance.org. And you can sign up for future webinars on our Phytobiomes Alliance webpage. We are taking a short break in the summer, so our next webinars probably will not be again until September, unless there's just something that we can't wait to get out. So thank you again, Claire and Rick, and to your collaborators who actually put the project together and who also prepared the video. So thank you very much, and we look forward to seeing you at our next webinar. This is Kelly Eversole. Have a great day.